The combined gas law is similar to Boyle's, Charles, Gay-Lussac, and Avogadro's law. But don't worry about that. But we talked about Avogadro's a long time ago. The more particles, the more moles. That's Avogadro's law. So it's you have P1 V1 over N1 T1 equals P2 V2 over N2 T2. And you see, watch this, guys. When you don't talk about your variable, you're going to see all the gas laws are here. So if you guys notice, where's the eraser? How do I erase?
You can't do it if you're not on time. I'm not even a teacher and I know this.
Nice job.
Good job, Renee. That's what you're becoming a teacher. You're going to become a chemist teacher.
Where's the eraser? I thought you said, oh. No, she's right.
You can take mine now. Sure.
So, guys, remember, if we're not talking about moles and temperature, what gas law are we using? What gas law is this? P1 V1 equals P2 V2.
Pressure.
No, not Charles. That's Boyle's law. So if we don't talk about,
You want to erase that.
no. I'm just showing you guys this. So if we're not talking about,
You're already on the eraser.
so if we're not talking about pressure and moles, what's our law? V1 over T1 is equal to V2 over T2. Whose law is that? Charles' law. So all the laws are involved in there, and I'll just show you that the other one's there too. I'm not lying to you guys. I'm serious.
What?
Yep. So if we're not talking about volume and moles, P1 over T1 is equal to P2 over T2. We're talking, no, that's Gay-Lussac. Gay-Lussac's law. P1 over T1. So all the laws are combined into this gas law. And that's why we call it the combined gas law. Okay? So, let's just try an example. Try this one here, guys. All right, guys. So, let's back up a second. So let's take a look at what I'm given here. Whoops. Let's take a look at what I'm given here and plug in my things that I know. A sample of gas occupies 200 milliliters. What does 200 milliliters represent? Volume.
That's volume 1, right?
That's my volume 1 at 150 Kelvin.
This temperature.
That's temperature 1.
1.5.
And at 1.5 atmospheres. Atmospheres represents
Pressure.
pressure. What is the pressure? So now I want to know what's the other pressure. So I want to know my P2.
You guys should do that too. Mr. Kilgore did a nice job. Like, when you know the unknown, put something there like an X or a question mark so that you remember when you're setting it up that you're looking for that.
So if the volume is decreased to 100 milliliters, what does that mean? It's decreased to 100 milliliters.
That's temperature 2.
Not temperature, milliliters is volume.
Oh,
So I have 100.0 ml. And the temperature is increased to 300 Kelvin. 300 Kelvin, that's my T2.
I think pressure times volume means pressure times temperature.
So, hold on. So what don't we talk about here? We don't talk about N at all.
What is N? What is N?
Moles.
Mole?
Moles. Not mole, moles.
You know what that is though, right?
Yeah, it's a sauce. It's a red sauce. I love mole. It's delicious.
I didn't think about that.
So, now our gas law that we have, guys, this is the easy part. Our gas law that we have here is P1 V1 over T1 equals P2 V2 over T2.
Oh, okay,
Just
let's
get-
do it now. Let's do it.
Okay, so now let's take a second. And
Yeah.
all right, we're recording. So moving on. This is for Vinny. So, So we got our P1, V1, and our T1. So let's go through this. So we have our equation. P1 V1 over T1 equals P2 V2 over T2, right? So we got all that down. So however you want, all you have to do is basically just substitute your variables here. You have your P1 1.5 times your V1, which is 200, all over your temperature, which is 150, equals my P2 V2 over my T2. P2, we'll call it P2, because we don't know what that is yet. My V2 is 100, and my T2 is 300. And all you do, you can use cross multiplication, you can use algebra, however you guys want to solve this problem, but it's going to be pretty, so it's 2 times 3, right? 1, 2.
Yep.
Yep, 2 times 3, which is P2 is equal to 6.
Okay, wait. Because at first I got 4, but I did it right. So
I got 6 points.
There you go.
now, bruh.
So 1 point, that's 100, 2 times 3. Yeah, it's 6 atmospheres. Good job.
Hold on.
And then I'd be okay.
We get up too early.
And then go to work.
Yeah, the children might get up at like 9. Those school starts at 9. They get up at 6. Okay.
No, that's weird. Those are their crazy.
We should come in at 9.
Oh, I thought they get up at 5:30 and I'm like,
I got up like an hour and a half before I had to be in the road. Like, wow.
All right, guys, let's do this. You guys are gonna be shocked by this. You guys are gonna be shocked, shocked and awed. Check this out. I know. Be prepared. All right. You know, if you need to put on your sunglasses because the glare is too much, because this is just too good. All right.
I need to take a seat for the glory that is this.
Yeah, you might have to. So you might want to lie down. Don't lie down. So a gaseous shield in a rigid container exerting 1,000 kilopascals. What's 1,000 kPa? Pressure. 1,000 kPa. At 27 Celsius, my temperature is 27 Celsius. 27 Celsius is equal to 300 Kelvin. What is the pressure? What is the pressure? What's my final P2? At a temperature of negative 73, at 200 Kelvin. Okay? So, what don't we talk about here?
V1 and that everything.
We don't talk about volume. So we got our combined gas law. We got P1 V1 over N1 T1 equals P2 V2 over N2 T2. What are we talking about? What do we get rid of? N and V.
V2 and N2 goes up.
No, we want to find P2.
You said N2.
Oh yeah, no.
So we got to get rid of all these guys. And there we go. Now we're ready to go. We got my gas law right here. Wait, that looks familiar. Weird, huh? P1 over T is equal to P2 over T2? Close. That is Gay-Lussac. 1,000 kPa over 300 Kelvin is equal to P2 over 200. P2, what's P2 equal to?
666.6.
Is that right?
7. Alright, well, I didn't force it like that because I don't need the double number. Right? Amen.
There we go.
Oh, 7. Alright.
You round up, right?
I don't.
Okay? We got this? Good. Alright, one more. We got to do another law. Another ideal gas law.
How am I going to remember which one
You're going to get the formulas.
I know, but how do I know?
We'll talk about that, okay? I promise.
But again,
Wait, should I?
oh, we're writing this down.
No. P is pressure. C is volume, and R is gas.
R is the gas constant. I better pause this. Go. All right. Ideal gas law is if you know 3 of them, you can solve for the other one. So R is a constant. So if you know pressure, volume, and moles, you can actually solve for temperature. If you know pressure and moles and temperature, you can solve for volume. So if you know one of the 3, P, V, N, or T, if you know 3 out of the 4 of those, you can solve for the other one that you don't know.
So you never solve it for R.
R is a number. R is a constant.
Alright.
It's the gas constant. It's pretty often. So, oops. So, oops, get rid of that. Copy the step. Yeah, that was scary. I tried that last year. It was too scary, so we got it. It was too scary. Kids had nightmares. Recording. Now, so guys, this number is R. This number is also R. And this number is R as well. These are the 3 values of R that we're going to use.
And this is the unit.
You can use any of them on any equation.
No. What you have to pay attention to
Are the units.
are the units. I think we may have mentioned that, Mr. Costa and I, once this year. Maybe, no? So you guys, units are very important. Units describe the number.
I like it.
So this unit is liter kPa per mole Kelvin. These are the units.
That's like every unit.
Yep. That's because R,
So what?
R involves every unit. R involves volume, pressure, moles, and temperature. That's what R is. That's the ratio of pressure, volume to moles Kelvin. So it'll always be this number. Except you got to pay attention to your units. Units will guide you. They will guide you to know where you want to be. So make sure you. I mean, you can also convert R. You can do a milliliter R, but don't worry about that. Just pay attention to the units. Really, most of the time we're just going to be talking about the different pressures. So, or if it's in milliliters, you got to convert to liters for the problem. So let's go through this one. Let's make sure you have these down in your notes. So let's try this example right here. 11.2 liters of a gas exerts 50.0 kPa at 100 Kelvin. How many moles of gas are present? So you guys, you want to go through this. Well, 11.2 liters, 50.0 kPa, 100.0 Kelvin. How many moles? Question mark. You guys got to pick out which R you use for this one. The correct one. One of them's correct. The other 2 are incorrect. Obviously, pay attention. All right, 11.2 liters. What's that?
That's P, volume.
11.2 liters. All right. Exerts 50.0 kPa. What's that? 50.0 kPa. Temperature. I mean 100 Kelvin. What's that? 100 Kelvin. How many moles? So I want to know how many moles. Now we got to go back and look at what R value. So let's go take a look at that. Let's look at my. What are those things called? No. Units. kPa, liters, Kelvin.
8.31.
So I go to find the one with kPa, liters, and Kelvin. I'm not going to use these 2. I'm not going to use these guys. Because that will give you the wrong unit. Then your satellite's going to blow up and your company's going to be out $1 billion and then you're going to get fired. Sorry, that's what happens. 8.5 trillion. 31 liters kPa per mole Kelvin. That's the unit. Okay? So now I can go back to my ideal gas law, which is P times V is equal to N times R times T. Just substitute. Easy. P times V, 50.0 kPa, times my V, 11.2 liters, equals n, which is what I want to solve for. I can keep that variable, or I can call it x, or I can call it y, or I can call it w. How do you call it w? Just
I don't
kidding.
know.
It doesn't matter. It's a variable. Who cares what you call it? Just solve for it and be happy. Is equal to n times r, 8.31 liters kPa per mole Kelvin, times my temperature, which is 100 Kelvin. And check this out, guys. You guys are gonna be so amazed. So prepare yourself for amazement. Okay. So what color should we cancel out? Green. Green. Good. So check this out. Look at your equation right here. We got liters here, liters here. They cancel out. We got kPa here, kPa here. They cancel out. We got Kelvin here, Kelvin cancel out. What unit are we left with? Moles. We're left with mole. Now just solve for n. N equals, oh, I can't do that. N is equal to what? What is n equal to?
0.6.
What are we doing here? Blue?
0.673.
Blue.
I don't know.
N is equal to 0.673. What? What's the unit? Moles. Mole.
That's weird. I would-
Just figure that out.
Oh, you good then?
All right. Just
Why do you guys do this?
you did the wrong math.
How you do it?
Just like this. Multiply this one, and then multiply this, and then divide. Okay. So, all right. At what volume? So what do I want to find out right now? Just at what volume? V. I want to solve for V. With 1.2 moles. What's 1.2 moles?
N.
N. Negative 23 Celsius. What was that?
250 Kelvin.
We have to convert it to Kelvin.
How do we do that?
We blend
You add 273.
Add 273, we get 250 Kelvin.
Oops, 0.8 is the pressure.
And then add 0.8 atmospheres. What's that?
Pressure.
Pressure.
0.8.
So now, let's go take a look.
It's 0.08.
Let's go back 2 slides. Do we use this one?
No.
Do we use this one?
No.
No. We use this one. Units.
Yeah, I
Units.
forgot the one.
0.0821.
0.08.
Liter atmospheres per mole Kelvin.
Oh, but it's only like a couple points.
It's fine. Yeah. If you just 0.0,
It's whatever.
0.082 is fine.
I got the same.
So I got, again, my PV equals N times R times T. And I want to solve for V this time. It's easy.
What's the combined?
0.80 ATM times my volume is equal to, what is it, 1.2 moles times R, 0.0821 liter atmospheres per mole Kelvin, times my temperature. Why am I writing like this? 250 Kelvin. So all I got to do is solve for V, and I get a number. So solve for that right now if you haven't done so yet. All right. So what do we get for V?
30.30.
250 times 1.2 times that divided by that is equal to 30 point.
75.
30 point.
What?
75.
Guys, make sure you're looking at the units too.
Why is it 1.8 for?
Round it to the tenths.
Oh, I don't know.
It's all right. Don't worry about it.
Okay,
Either
good.
way, you still gotta write it.
Actually, this should be only 31. Round to the ones. All right. One more thing, guys, before we move on.